Alright guys, so we are about to fit this forecasting model, and we're going to fit this stuff in column J on the left hand side, and then we're going to put columns D through G on the right hand side. And I mentioned at the end of the last video we have to leave out one of the categories, and we're going to leave out the very poor category. And you're probably wondering, why the heck do we have to do that? And the reason is, if you add up all of these numbers, you should get to 100%, 100. And that means that this combination is a linear combination of the rest of them. You can just take 100 minus excellent, minus good, minus fair, minus poor, and get the thing in the very poor category every single time. And if we tried to put all of these categories in the regression, it's going to mess things up. The reason gets a little bit wonky, but I want to give you the basics of it, and then you can maybe know it at an intuitive level, and if you learn more statistics, then you can maybe understand more advanced statistics. So the general equation, I'm just going to type it in here so we can have a frame of reference. It's y equals beta times your x variable plus epsilon. Okay? Let me make that bigger so it's easier to talk about. Okay, and it just says we're going to take these x variables, and in more advanced econometrics you can have a matrix of x variable realizations, like this is a matrix, this rectangular thing of data. And then your y variable is a vector, and you're literally trying to pick a vector of betas that can transform this vector of x data into giving you a good prediction for y with some uncertainty that's reflected by this epsilon. Now it turns out, I won't work through the math of it because it would require me using matrices and linear algebra, and that's beyond the scope of this course. It's not that it's hard, but it's definitely beyond the scope of this course. So the way that OLS, ordinary least squares, gets you the answer for the betas when we actually do the regression that we do in Excel is it gets beta is equal to, and I'm just going to put it here and we'll talk about it conceptually. Excuse me. X transpose X inverse X transpose Y. Okay. Make it big. Alright, so these are matrix operations. This X transpose is the transpose of a matrix. X transpose X. Inverse is a inverse of a matrix. And all of this stuff gets you, if you do all those matrix calculations, you end up with a vector of betas. So those beta, those intercept first regressor, second regressor, third regressor, numbers that spit out from the regression output when we fit a regression in Excel. It's from this matrix formula. And the reason I had to show you that is it's related to why we need to leave out this very poor category. Now, an inverse of a matrix is very similar to an inverse of a multiplication for numbers. And you all are aware, I'm sure, that you are not allowed to divide by 0, right? You can't take 6 divided by 0. The world explodes if you try to divide by 0. So you also can't divide by 0 in matrix land, and in matrix land, dividing by 0 is the same as saying the inverse doesn't exist, or the determinant of the matrix equals 0. And it turns out, if you have a matrix whose columns are linearly dependent, which is the case for this kind of data, because very poor can be found by saying 100 minus excellent minus good minus fair minus poor. You try to take the inverse of a matrix like this, constructed in this way, the determinant will be 0. It's the equivalent in matrix land of trying to divide by 0, and the whole thing blows up. So that's why you have to leave one out. And it's kind of a hand-wavy, convoluted explanation, but That's really the real deal. So with that, let's carry on and fit this forecasting model. So I'm going to go to my Data tab, and I already have the Data Analysis menu here. If you're working at home and this section doesn't appear when you click Data, remember you can come over here to File, Options, click Add-ins, and Excel add-ins is what you want, so click Go. Make sure you have the Analysis Toolpack selected, click OK, and you'll get this menu. So open that up, scroll down to Regression, click OK, and then we're going to select the Y variable as the % deviation from trend yield. So I'm going to get all of that data. My X range should be beginning with the poor category. Excuse me. And I'm holding down only the Shift key to go over one column at a time. So I should get poor through excellent selected. And let me select where I want to put this output, and I'll just drop it right here, right here. Okay. All right, so we have a regression, and look, we have an R-squared of 95%. That's great. And let's see if we have statistically significant predictors. And we do in a lot of cases. The intercept being not equal to 0 tells us we usually expect to have observations above the trend. That probably reflects the fact that when we're below the trend, we're below big, but we're more often above the trend than below the trend. And then when we're below the trend, we get some indication from these predictors. So we're getting a lot of mileage out of the good and excellent category, which may be why in the media people kind of ignore these poor and fair categories and focus on the good and excellent categories, because we're getting a lot of prediction out of that. Okay, so that's great. And we can use these results to make predictions about yield realizations within a crop year. So the way that we're going to illustrate that is if you click over here on sheet 2, there's a bunch of other data, and it's organized a little more complicated way, because for every week of every year we get these crop progress and condition reports, right? And notice that these start in May, and this is for year 2018, and we get one every week all the way through October. And then in the data, we're starting to get back 1 year ago's data. And you can see the excellent, fair, good, poor, very poor is there as well. Okay. So to get our predictions, what I want to do, let me just copy and paste these forecasts over for us. And we can use that to reference our forecasts. So these are our yield forecasts. And the way we get our yield forecast is from the values in these categories. So it's going to be equals our intercept plus, and we start out, we're not using very poor, we start out with the poor category. So variable 1 is that times our poor variable plus the second variable times our good variable plus variable 3 times our oh, I see that these are alphabetical, and that's not the same as the actual condition, so that's going to mess up our forecasts a lot. Just for reference, over here, notice it goes, our X variables go poor, fair, good, excellent. And we're going to need to make sure we do it in that order here. So equals intercept plus this beta times poor plus this beta times fair plus this beta times good. Notice how those are out of order. Plus this beta times excellent. And I can't grab that very well. So I just clicked the cell above it, and now I need to edit that row to column to row 2. Okay. So we do that, and then we need to carry these down, but notice, like, there's this whole block of data associated with week 21, so we're not going to get a new yield forecast in each of these rows. It's not going to be till this next week rolls in. So I'm going to take this variable, this formula, Control C, and then drop it here. Except it would be a better idea to make sure we pin down these beta estimates. So I'm going to go through and press F4 for everything in the J column, so that when I drag that down, it's not going to move. Okay, and now do my Control C, Control V. Okay, so this forecast moved a little bit, but not a lot. And you know, from the end of May to the 1st of June, you wouldn't expect to be able to find that much. But now that we have this, we should be able to scroll it down if we're careful about how we do that. So we've got this pattern where we have a number and then 1, 2, 3, 4 spaces. Number, 1, 2, 3, 4 spaces. So I think if I do that, it should fill down our forecasts appropriately, and I think it does, because we should be getting one every time we see an excellent rating that marks a new week rolling over. Okay, so you can see what's happening intuitively here. We start out in May and we get expectation of about 6% over the trend line, 7% over, 7 sort of bouncing back and forth. Let me just verify that these formulas are correct. And then we start getting into July, and it starts deteriorating. Now we're 5% over, now we're 4% over, 3% over, and then sort of, now we're at the end of 2018, and we're left with 3% over, which is pretty good. Okay, now in the next step, what I'd like us to do is, you can see I have that data filtered, but that'll come next. So I'm going to take it off so it looks like yours. These are my yield forecasts. Percent deviations anyway. Actually, let me make that a little more. Because that's going to end up being the title of our chart. So I want to make a chart, excuse me, with these expected percent deviations against weeks. So I'm going to hold down the Control key and then go to Insert, Charts. And actually this time I don't want to do a XY scatter plot. I want to do a column chart, I believe. Yeah, let's do a column chart. We can change it if we don't like it. This looks pretty good. It may look like it's bad, but it's going to work out pretty good. Now, what I want to do next is, this is plotting all of the years against these weeks. And that's not very insightful. It's much more insightful to look at it year by year. So we can filter the data and only display a year that we want to display, and that will help us see how these forecasts are changing as we move through the growing season. So I'm going to actually cut and paste this chart to the bottom so that when we're filtering out the data, our chart doesn't get lost in that movement. So highlight the chart, do a Control X, and then get to the bottom of the Excel spreadsheet, and then drop the chart down there. Okay. So that looks good. Let's go up here and see what it looks like when we filter out everything but 1 year. So I'm going to highlight the whole rectangle by clicking there, then go to our Data tab, Filter, and let's choose just 1 year. So let me choose something that is a pretty good year. I think 2016 was a good year. And let's see what that chart looks like. You can see how our forecasts are coming along. In May, we're above trend. July, we're looking even more above trend. By August, we're looking above trend. And these are just plotting as bars. The height of these bars is our what our forecast for percent deviation from trend yield looks like. And you can see starting out at 21, we get this sort of baseline estimate. That's going to be pretty early in the year, like May or something. And then by the time we get into midsummer, which is around here, we're pretty much stabilized because we didn't have any adverse weather. Let's take a look at what happens if we choose a different year, like, for example, a really bad year, like 1988. In 1988, we get a very different story. You see, we started out a little bit bad on the expectations, but we quickly, as we moved through May and June and got to July, we are looking at a pretty bad expectation about what the yield is going to look like. And remember, that was a minus 23% realization. And we can see here in 1988, our last forecast was actually minus 24%. So this forecasting model overshot by a little bit, but not very much. And then this was 1988. Let's look at another bad year. The most recent one, which was 2012. So unselect everything, scroll down here to 2012, and you can see 2012, we started out like a typical year in the spring, April and May, having positive expectations, and then as June and July roll around, you can see those quickly deteriorated. And at our worst, we thought we were a little bit worse, but rebounded at the end. In September, we thought we were going to be minus 20. And in fact, we ended up being minus 23. So our forecasts at the beginning of September were actually closer to the realization than the end of September, which I wouldn't have expected that, but that's how it goes. So there you can see these, you can see how these would be useful, especially in these June and July weeks where we're learning a lot by these crop progress reports coming out every Monday afternoon. And having lived through 2012, you can definitely see the market immediately reacting when you see something that looks like this. And that is definitely kind of what is moving prices as these reports come in, what everyone is suspecting looking out their windows that the crop is not doing well. You get this confirmed at a national scale, and it moves markets. Like I said, everybody else who's paying attention to commodities are looking at these same numbers, but this gives you a quantifiable number with a very simple regression model that is doing actually quite well. So I'm just going to take a couple minutes in the next video to give you some tools on how to at least plot and think about how well you were doing in these in this exercise. So stay tuned for that.